All right, guys, this is the second video, and we're going to be doing, let me just slide this up. We're going to start our basic gas laws. So the first one we're going to talk about is pressure and volume, and you're coming to this video after you have finished the lab. So in the lab, you took a pressure bottle and you put inside of it a cap syringe, and it had a volume. The syringe had the volume of like 4 or 5 milliliters. And what you did was you increased the pressure in the bottle and you watched what happened to the volume in the syringe. And what you saw was that, just like in this picture, if this was a syringe and you had this initial 4 to 5 milliliter volume, as you increase the pressure, so here we're increasing the pressure, the volume dropped. You saw that syringe actually begin to compress without touching it, which was pretty cool. So what we saw was that as pressure goes up, so as pressure increases, volume decreases. And one of the assumptions that we're going to make for all of these basic gas laws is that there are constants for our system. Constants for the system, and we're going to represent that as a K. So in other words, there's a maximum volume pressure ratio that we can have, and we're going to call that the constant K. When we have a relationship where when one variable increases, the other variable decreases, we call this indirectly proportional. And the way we would represent this mathematically is we would say that our pressure times our volume is equal to this constant K. So one of the things that you need to know, especially for physics, is that when variables are on the same side of the equations, we have variables on the same side of an equation, they are indirectly proportional. Indirectly proportional. So an example of in physics, I'm just going to grab another equation, and this is certainly not something you need to know for chemistry, but we know that Newton's second law says force equals mass times acceleration. It's an M. So what we see is that mass and acceleration are indirectly proportional. As the mass goes up, the acceleration goes down. As the acceleration goes up, the mass would have to be dropping. So that's an indirect proportionality. The more important part of this chapter is understanding relationships. And you're going to be doing some practice mathematical equations, but what you're going to see more of are multiple choice that are going to ask you about the relationship between pressure and volume, whether they're indirectly or directly proportional. The fellow who discovered all of this was named Boyle. And so all of these gas laws get named after the guy that discovered them. So we have Boyle's law. Boyle's law. And if you look at initial and final pressures and initial and final volumes, the equation becomes P1V1 equals P2V2, where P1 and V1 are initial pressures and temperatures. So this stands for initial. And the 2's stand for final. So if we look at the initial pressure and volume and the initial, we can calculate, and we have one of the final values for either pressure or volume. We can find the third. So let's do a sample problem, and then I'll come back and give you guys a mnemonic for how you can remember Boyle's law. So if a gas has an initial pressure of 1.5 atmospheres and a volume of 300 mils, what is the volume when the pressure is 200 kilopascals? What I like to do is I like to make a variable bank for these problems. We have P1, V1, P2, V2. So our initial pressure means the beginning pressure, and that's 1.5 atmospheres. Our initial volume is 300 mils. What is the volume? So when you find that question word, you're going to put a question next to that when our pressure is 200 kilopascals. All right, so we've got some unit issues we have to take care of. First of all, remember the unit for volume is liters. So I have to convert 300 mils to liters. And if you remember, we're going to move the decimal 3 places to the left. So this is going to be 0.3 liters. And then I have my initial pressure in atmospheres and my final in kilopascals. And so that can't be. So I'm going to convert kilopascals to atmospheres. If you remember, we're going to do dimensional analysis. So I have 200 kilopascals. I'm going to put that over 1. And if you remember, we've learned that 101 kilopascals is equal to 1 atmosphere. Cancel my units. And when I multiply and divide this, I get that this is 1.98 atmospheres. So over here, I'm going to put in 1.98 atmospheres. Now my units are all cleaned up and I can solve the problem. My formula is P1V1 equals P2V2. So I'm going to have 1.5 times 0.3 equals 1.98 times V2. That's what I'm solving for. And when I solve my algebraic equation, I get that V2, did I calculate this out ahead of time? I don't think I did, so I need to grab my calculator. 1.5 times 3 is 4.5, and when I divide that by 1.98, I get a volume of, pause this. Okay, let's try this again. 1.5 times 0.3 is 0.45 divided by 1.98 is going to give me 0.227, a volume of 0.27. So V2 is going to be 0.227. I said 4.5 because I multiplied it by 3. And when I got my answer, and this is going to be liters, I got 22.7, and that's a ridiculous answer. It actually kind of brings up a good point, though. You want to make sure, excuse me, when you get your answer, that it makes sense. And that first answer I got didn't make sense because when I punched it in, I punched in 3 instead of 0.3. And so I got a ridiculous answer. It makes sense that I would go from 0.3 to 0.227. But what we saw is my pressure went up, my volume went down. So that's a good answer and it makes sense. So one of the things you need to remember for the test is that Boyle's law is pressure and volume related, and you need to know how they're related, if it's direct or if it's indirect. So you've got to remember these 3 pieces of information, and students tend to get confused. And so one of the things I did was I came up with a mnemonic that you can use to remember Boyle's law. So I want you to take the boy and Boyle's, and a lot of boys today, now I'm being a little bit, I suppose, sexist by saying that boys are the only ones who play video games. I know a lot of girls play video games, but we're going to say that boys predominantly play video games, and they get online, and so they play with their friends, but they don't do it like in the same room. They do it indirectly. And so the mnemonic for this is that boys indirectly play video games. So how does this help you remember? Boyle's law is an indirect relationship between pressure and volume. Boys is Boyle's. Indirect means they're indirectly related. P is pressure, P is for pressure, and V is for volume. So if you use these, it will help you remember that Boyle's law is an indirect relationship between pressure and volume. And I have students that go to college and they'll contact me and say, oh yeah, I still use those mnemonics. Help me remember and retain that Boyle's law is the relationship between pressure and volume. So what are our takeaways? We hit our first gas law. We saw that variables on the same side of the equation are indirectly proportional, which means as one goes up, the other goes down. Talked about Boyle's law and a way to remember Boyle's law. And then we worked a sample problem. And we made sure that we noted out to your units have to be in the correct form. Okay, let's move on to the next gas law or two. Thanks for watching.